Predicting single reaction by Alex and Teresa. Step number 1. Write the formula. Iron is Fe plus Pb for chromate. So Pb and then chromate is CrO4. Because chromate is CrO4 -2, this would be 2 over here and this is 4, but you cancel those out and this becomes PbCrO4 2. With a single displacement reaction, you are now switching A over here, and this is B, C, and you're switching B and A. In order for this to happen, you have to check your activity series.
Wait, what are you doing? Wait, how is it working?
Check to see if Fe is above Pb. Fe, Pb. So that's okay.
My hand.
Now
That's weird.
it becomes FeCrO4. This is still -2, so now you need to check your periodic table to see what charge iron is.
Do you have like your tilt on?
Iron has a 3 charge, so now these don't cancel. So it's Fe2, because this is -2, remember? And chromate, CrO4, 3. Plus your new lone element, which is lead, Pb. Because this is not a diatomic element, it will not have its charge there. Okay, so now that we have that, let's rewrite it. So, you started out with Fe plus PbCrO4 2, single displacement, and it becomes Fe2 CrO4 3 plus Pb. States of matter. This is a solid. You can check your periodic table. Chromate. You should be able to check your solubility rules. You should know them, but if you don't, double check. And chromate is only soluble with group 1 and NH plus 4, which Pb is not in group 1, so this is a solid. And then this again is a solid because iron is not in group 1, plus Pb, which is a solid. And now you have to balance it. So there's 2 here, but there's a 3 here and there's a 2 here, so you need to make this a 3. Or you need to make this a 2, this a 3, and then you would make Pb is now a 3, and because it's 2 times 2, this becomes a 4. So your final product,
Okay, and then for the next step,
written neatly,
you're gonna have to be finding the limiting reagent.
is that. Our second problem is manganese 3 chloride, and nickel. So going back to our formula rules, we need to write the formula, write the states of matters. Is it a cation or anion? What part of the compound will it replace? Check activity series. This is going to be a big one for this one, and we'll get back to that later. And then once that's checked, go into new formula, state of matter, and then same for the lone element, balance the equation. But first, let's write the formula, which is going to be MnCl3. Now, if you remember from your periodic table, Cl is 1, so therefore nothing's going to cancel, and because manganese they gave us the charge is 3, it's going to be like that, plus nickel. Writing your states of matter, chloride is going to be soluble, which makes it aqueous, because it's soluble with manganese is not one of the exceptions, plus nickel, which is solid. Okay, so now it's time to check the activity series. We need to make sure that nickel is higher than manganese. But if we go and look at our activity series, manganese is higher than nickel, which means that this cannot be a reaction. So when this happens, you write no, NR, which means no reaction, and you're done.
Question number 3. Hydrogen and silver hydroxide. First, we're going to write the formula out. Start with H2. You have to remember that hydrogen is a diatomic element. Plus silver hydroxide. Hydroxide, polyatomic ion, if you don't know, is OH negative, and silver on the periodic table gets a 1 charge, so that is just AgOH. Make our arrow. Now we need to check our activity series to see if it works. We're going to check, let's see, silver and hydrogen. So hydrogen is higher than silver, which, since that's the lone element, the reaction can work. So it will be this element and this element switching. So I'm going to skip down to here. It's written as HOH plus silver, which is now the lone element. Our states of matter. I'm going to erase these. Everyone saw that. H2 is gas. AgOS is not aqueous, so we write that as solid. HOH, that is also water, so it's a liquid. And silver is a solid. Now all we need to do is balance it. We have that staying the same. You get a 2 right here, which means the silver on this side needs a 2, and the 2 hydrogens on this side, we need 2 because oxygen needs 2 oxygens up here. So I'm going to make this a little neater. Your final answer is H2, which is a gas. 2 AgOH solid yields 2 HOH liquid plus 2 Ag. That is a solid. Sorry for that. Final answer. Question 4 is iron 2 iodide and bromine. Our first step is to write our formula. Start out with FeI2. We're going to show the crossing. Fe has the 2 charge. Iodide on our periodic table, it's a 1 charge. So just negative, cross those, and you get FeI2. Plus Br2 bromine, that's a diatomic element, yields. We need to check if the reaction can happen. We're going to check over to the anion side, bromine and iodide. Bromine is higher than iodide, and bromine is the lone element, so it can happen. So now you're going to have this. Well, your iodide will be the lone element. So 2. You're going to get FeBr3 plus I2. Since iodide's the lone element, it's also a diatomic, so it gets I2. We need to add our states of matter. FeI2, if you go over to your solubility rules, it is aqueous. Aq plus Br2, bromine, is a liquid, yields FeBr3, that is also aqueous, plus I2, careful, it is a solid. Next is balancing. It is 2, 3, 2, 2, 2 giving 4 iodides on this side. You get 6 bromines, and 2 irons. So, to make this neater, our final answer is 2FeI2 aqueous plus 3Br2 liquid yields 2FeBr3 aqueous plus 2I2 solid.
If you're confused where the FeBr3 came from, iron has a charge of 3. It's only iron 2 and the iron 2 iodide.